Now, this one is just speaking about the multiplexing of HARQ acknowledgement. What it means by that. For example, the user need to know how many bits or need to use in the uplink to be able to send the feedback. So there is two types actually of the multiplexing of HARQ acknowledgement. Multiplexing means that different HARQ can be sent together and so on. Okay, so there is two types: something called static codebook, as mentioned above here, and dynamic codebooks. Actually, in general, it's three types, but the third one recently introduced. There is not too much information about it, but the most common one, which is currently used in majority of the network, would be the dynamic one. But I'm going to explain the differences between them. But first, what it means again by multiplex of HARQ acknowledgement. If you read here, that the HARQ acknowledgement codebook defines how HARQ acknowledgement or NACK are sent from UE to GNB. For example, this codebook, which is this time, allows the UE to multiplex HARQ feedback across. For example, let's assume that you have two transport blocks. So you need to multiplex the information, or carry aggregation, or different CBG retransmission. So you might need to send the feedback for all of them, as I will explain shortly. Okay. First of all, as you can see in this example, static, what is the difference between static and dynamic codebook? The static one, for example, assume that this is just a very simple high-level one. I will explain the details in the next slide as well for each one of those. But assume initially here there was some transmission and DTX, nothing being transmitted, this continuous transmission. So assume the data being sent slot here, slot 1, slot 0, slot 1, slot 2, nothing, and so on. Okay. So what it will do in the static codebook, it just have a fixed number of bits. It will send the feedback either it's received transmission or not. What it means by that, for example, here it's received to TX transmission, so it will send here a UE with feedback with acknowledgement, and for both of them. So in case if he didn't, the GNB even didn't transmit anything, because it's having a fixed number of resources, it will send also non-acknowledgement. For the GNB side, it knows there is nothing here, so it will ignore it. So this one is good, that will have a kind of alignment between the UE and GNB, BTS and GNB, because the user, even if there is nothing here, will still sending a feedback. So GNB will know, so this will not cause any conflict, as I'll explain shortly. And here, for example, this transmission was being missed, so non-acknowledgement being sent. So this is again, BTS can link the feedback because the user is sending ACK or NACK for each and every single transmission, or even discontinuous transmission. So in case if this one was not being sent as non-acknowledgement, okay, so the BTS might get confused because it will not know that next feedback is for which transmission. I will explain this one in details later, but it's just keep with me now. Here, just simply the static codebook send the feedback with a fixed size provided by RC message for each and every single transmission, or even discontinuous transmission. So this will be able to BTS to maintain the relationship between the transmission and the acknowledgement. This will be easy for the GNB. The dynamic codebook actually that is giving more flexibility, because at the end, for example, assume here there was nothing being transmitted. So in this case, you are wasting your resources to send a feedback here, even if there is nothing, right? So this is actually a job from this particular dynamic. Dynamic, in case if there is no transmission, it will not send anything. It will not send any like a feedback to save the resources. So this is kind of saving the uplink resources here. But now assume the same example here, the transmission being sent here, and this one was being missed. Then so assuming this one was being sent here and this one was being missed, so because it's missed, it's nothing being received by the UE. So in this case, it will not send anything because this is the dynamic phase. Dynamic, it will not send any feedback to save the resources. So this means this transmission, there is no feedback being sent from the UE. So the next one transmission, the UE replied with acknowledgement. So the GNB will think, because this one there is no feedback for it, the GNB will think that this acknowledgement for this particular missed transmission, and this is might cause a conflict. And this is actually the gain of the static codebook, that because it's sending for every and each single transmission or even non-transmission, ACK or NACK, so it's very easy to align from the BTS to align the feedback. However, this one, Yes, it's saving kind of resources on uplink, but this kind of missing feedback might cause this kind of conflict from the BTS side. It can lose the relationship between the transmission and acknowledgement, as happened in this scenario. However, there is a solution for that, which is called DAI. I will explain this one next slide as well. But just keep it in your mind. We have this static codebook and dynamic codebook. Just both of them to decide the whenever the how the acknowledge and non-acknowledgement, what is the resources using number of bits used by the uplink for the UE to be sending this kind of information, as we highlight in these two examples, and the dynamic in general giving a better resource utilization, like reducing the uplink feedback because it's reducing number of bits required to send a feedback in the uplink, but it can have some conflict, but this is already being solved with this DI, as I will explain next. And this is just explaining the main differences between semi-static codebook type 1 and dynamic codebook type 2. For example, this one size is fixed, as I mentioned. It has fixed number of bits to send the feedback. But again, this is introducing extra overhead, as mentioned here, because it even includes unused HARQ and NACK for the DTX, for example. While size for the dynamics adaptive can be high or low, depending on the requirement, and flexibility is much higher, and it's having lower yield. Okay, this one having high reliability for sure, because sending feedback for each and every single slot, despite there is a data or not. This one having a lower, but however, this can be fixed, as I will explain in the next slide and so on. So the multiplexing capability, this is actually can almost you can see close to each other. However, dynamic is also still better. So this is the main differences between both of them. I'll explain again with some examples, quick examples, how this is working, especially for the dynamic codebook after solving this kind of problem. But there is also the dependencies from the UE. The UE showed supporting both of them. I'll show this, and also the network capabilities. Let's move for next to cover both of them. The semi-static was kind of doesn't look very clear from the previous example, so this one it would kind of make it more easy. Assume you have three carriers, okay, as from GNB side. There is a transmission from three carriers, as an example. And these three carriers will be sending the feedback in the BCH for the master carrier, in the first carrier. For example, was carrier from the top here. So assume the first carrier have one carrier with one transport flock per slot. 1, 2, 3. I have 3 transport flock. So you need to know when the acknowledgement will be being sent for all of them. We know all of them will be sending here, but we need to know what kind of information we have. We need to know as information of bits and so on. And here also one carrier, this one having one carrier, but up to transport block. For example, the first one slot having one transport block, while this one having 2 transport block. In case you have 2 transport block, this means you need to send 2 acknowledgement, one for each transport block, okay? So it will have 2 acknowledgement. The last one, actually, it's having multiple CBG. This transport block was being segmented, so it needs to send even 4 acknowledgement each for one of each code block group, and 4 here. So if you look into this, the figure bottom here, this was the transmission from the GNB. From the U side, you have a fixed number of bits information. This is a like you can consider as a view search. So we have a fixed number of resources. So you know, for example, in the first one here, the information received for the to be reported the acknowledgement after 4 slots. So you know that you need to send acknowledgement and non-acknowledgement after first 1, 2, 3, 4. So you'll send it here. So this one will be sent. But for this particular area, there was nothing. So as you can see, this one, as mentioned, an N. There is no scheduling here happening. But still, in the same time, this one will be used as number of bits. Even it's not supposed to be used because there is no transmission, but because of the static, as I mentioned before, it have to send the feedback anyway. So because no transmission here, so this one will be considered as non-acknowledgement here. It will send non-acknowledgement. In the case of dynamic, as we explained, this one will be empty. There will be no information, so it will save some of the BUCH resources on uplink. And it will be repeat the same. For example, here one carrier was up to 2. So the first one will be need only 1 acknowledgement. You can see there is 2 rows here because you have here 2 transport flocks, so you need to send 2 acknowledgement. So you have 2 rows here. But again, all the N will be sending again a feedback, so this is increasing the BUCH resources, so this impacts your capacity point of view. The third one, for example, here, again having 4, so it needs to send 4 acknowledgement for the first one. Second one, nothing. So again, it will send 4 non-acknowledgement, increasing your resources. Third one, 4 acknowledgement, and here there is nothing. It will send 4 non-acknowledgement. So as you can see here, as alignment for the feedback between JNB and DE, it's very good because JNB is receiving, it can having, it have no conflict between which one being acknowledged or non-acknowledged for the transmitted slots or data. But at the same time, from the network perspective, this is not good for the BUCH resources because this is impact your capacity point of view. And this is where we're going to explain more in more details the dynamic one. We already explained it, but we explain what is the solution to solve this kind of conflict and whenever it's there, received, and so on. So again, from the advantage point of view from the semi-static codebook, that it's predictable and robust because it's having fixed size, feedback structure as shown here, and this ensures the network always knows where to expect the HARQ-ACK responses. Okay, and it's having a fixed size and even no data received. But the main again disadvantage that it's increasing, it's wasting like kind of resources for the research. Now let's move to the next one, which is a dynamic codebook. Okay, again for dynamic codebook, actually, if you look into this figure, the figure in the top here, this was the problematic figure which I showed in the previous phase. That, for example, if here the BTS send TX and DTX here, and because this one dynamic, so that you know that he should send nothing here, but the next transmission was being missed, not received, so the user also will not send anything here. The next one was being acknowledged, so the user responded, so the unit B will think that this acknowledgement is for this TX or this slot, not for this slot. This is where from the conflicts coming. So there should be something to let the user know this transmission for which slot. There is something called, and this is where something called DAI, okay, downlink, it's called downlink assignment index, where it's telling him, it will inform the user this transmission for which, for example, slot. For example, here you can see there is something added called cDAI, counter DAI, again downlink assignment indicator. For example, this telling him C1 TX, this is for C1. This means this is the first transmission. Then again acknowledgement, he will know this one for C1, so he will be able to send the feedback as an acknowledgement for C1. Then C2, then DTX here, okay. Then he didn't receive it, okay, so he didn't receive C3. Then he received C4, so he will understand that he missed C3 because he received directly C4. So in this case, he will be able to send a non-acknowledgement because he will tell the B, I didn't receive C4, I received directly, I didn't receive C3, I received directly C4. So please report again the C3 through sending non-acknowledgement here. So this will avoid this kind of conflict. And again, this is through something called downlink assignment indicator, cDAI. And in case of multiple carriers aggregation, there is something addition on top of that one called Total DAI, which is help you determine total number of downlink assignment. So both of them work to identify which transmission was being missed, both of them together. And again, this is very much better compared to the static one, because this is like saving a lot of resources here, and instead of having a fixed resources and limitations. So this one reduce overhead and can save the uplink resources by avoiding this kind of fixed size feedback. And this is actually also adaptive feedback, so it can also, if you have many carriers and mean transport blocks and you need a lot, so it can increase the resources for that part. So it's working in an adaptive way, increasing the resources of BUSH whenever required, using it whenever also it's not required to send any kind of feedback. So from the network capacity perspective, this is very good. You need to check this one in your network, in your vendor, the capability of the device, whether it's supported or not, as I will show you how to do that in the next slide. So this slide, as you can see here, from traces perspective, again, you will go to the UE capability message. From the UE capability message, you will look for the physical parameter common. Under that one, you find that it's a dynamic HARQ-ACK, static, semi-static HARQ, and so on. Okay, so we'll find whether this one is being supported and on, and same for this another device and so on. Here, from the JNB side, there will be, I don't have like kind of traces for that, but from JNB side, from the UE, it will deriving under our serial configuration message telling them you are going to be using the semi-static or dynamic. It will tell the user. So this kind of network configuration. So we'll find, for example, from the traces, as I give an example, I give it manually here, BDCH HARQ-ACK Codebook, for example, telling them you are going to use dynamic codebook. So this is giving more flexibility and can improve your BUCH capacity. So this is something actually very useful for the network.